8.2 takes what we did in 8.1, that figuring out the greatest common factor, and takes it one step further where we actually factor. And I actually, like I said yesterday, I actually find this kind of fun. So steps for factoring, we're going to go through several different processes. We're going to go through kind of one process today. But first thing is to, step one, find the GCF. So really you're just taking what we did yesterday, and that's your first step if you want to factor something. What, of all these different terms, what do all the terms have in common? What can you pull out from everything? And then once you have that, then you want to pull that out. So number 2, pull the GCF out of each term. And kind of the layman's words for terms is clump, but like this thing here, we called this a binomial. This 4x squared is going to be one term, and then this minus 12x is going to be another term. So you have to say, what do they both have in common, and then pull that out. And essentially, what you're doing when you're pulling something out is you're taking each of those monomials and you're dividing. So divide each by the GCF. Okay, now let's actually do some of this factoring stuff. I'm going to start out with Roman numeral 2, monomial greatest common factors. And what we're going to do is do those 2 steps, find the greatest common factor and pull that out. Okay, so to find the greatest common factor, I look at the coefficients, the 4 and the minus 12, and look at those first, figure what could I divide both of those by evenly, and then I look at my x squared and my x. So 4 and 12, greatest common factor of them is going to actually be a 4. So I'll write down my 4. And then x squared and x, they both have at least one x, so then x is going to be my variable, my greatest common factor. Alright, so 4x is the greatest common factor of these 2 monomials. And then we just have to say, you could look at it 2 ways. Either what do you get when you pull out of 4x, or what do you look at it when you divide by 4x, or you could say, what would I have to multiply 4x by to get back to this? But if I were to do the division, if I have a 4 divided by 4, that just gives me a 1. If I do an x squared take away x, or divided by x, that's going to give me just 1x left. So 4x squared divided by 4x is just an x. Another way to look at it would be, like I said, multiplication. 4x times x would get me this 4x squared. Alright, for my next term then, I have this minus 12x. So a negative 12 divided by 4 gives me a negative 3. And then my x divided by x just gives me 1. They kind of cancel each other out. So I'm done with the problem. And you could check it, like I said, by saying, well, 4x times what would get me a negative 12x? 4x times a negative 3 would get me the negative 12, and then still have my x. If I were to take and do that for the second one, I'm going to do it kind of in those 2 parts again. I'm going to start and say, okay, negative 14 and negative 10. What could each of those be divided by? And for that, I'm going to say, all right, a 2. So I'm going to pull out a 2, so I'll write a 2 down. And how many x's can I pull out? Well, this has an x to the third, so kind of like 3 of them, x times x times x. This has an x squared, x times x. So they both have at least an x times x, so I'm going to pull out an x squared. And then, if I do that, so negative 14 divided by my 2 gives me a negative 7. And x to the third divided by x squared, well, I'm going to have 1x left. And again, if you wanted to check your work, you could look at it multiplication-wise. You could say, all right, negative 2 times negative 7, yup, gives me negative 14. X squared times x gives me an x to the third. And now I do the same thing for the next part. I have a negative 10 divided by 2 gives me a negative 5. And then an x squared divided by an x squared just cancels out all my x's. So I'd have that there. Now I hesitate to mess with your head too much at the beginning, but if you notice I still have these negative signs inside. And there's more negatives there than positives. There's 2 negatives, there's no positives. What they often will do, the goal is kind of to simplify this, to pull as much out as possible. So they'll say, all right, well, what if I had instead pulled out a negative 2? And if I had done that, negative 14 divided by negative 2 would have given me a positive 7. And negative 10 divided by negative 2 would have given me a positive 5. So if you really want to do it the best way possible, that's kind of how they would have ended up doing it. They would have pulled out the negative. So if you notice as you do a problem you have more negatives than positives, pull out the negative. Give that a shot. All right, last example of this kind is going to be down here. And I'll say, all right, I have a 8, a negative 4, and a 16. So what could I divide each of those by? And that would be a 4. Then I look and say, okay, they all have x's, they all have at least 1, so I could pull 1 x out of each. And then 8 divided by 4 gives me a 2. And then I'll have 2 x's left, so x squared. So I had an x to the third, I'm taking away 1. Then I have a negative 4 divided by 4, just gives me a minus 1, so I'm going to do a minus. If there's no x's left, then I'll have to actually write in the 1. But I have x squared, taking away one of them, so I have 1x left, so minus x for my middle term. And then last term I have positive 16 divided by 4, gives me a positive 4. And then I have 1x there, but I'm taking 1x out, so no x's are left. So that would be the third example. All right, Roman numeral 3, binomial greatest common factor. This is really just setting us up for Roman numeral 4. But this is going to be where all the terms have a common binomial you can pull out. So if we look, this here, this x plus 2 is really all connected together. That's one thing. And it's connected to the 5 by multiplication. So my first term is this 5 parentheses x plus 2. My second term then would be this positive 3x times x plus 2. Again, that's all one clump. And now if we look at both of those, they both have an x plus 2 in it. So we can pull out the binomial x plus 2. And when we do that, when I look at this first part here, if I take out the x plus 2, all that's left is the 5. Or you could say x plus 2 times what would give me 5 times x plus 2. And it's x plus 2 times 5 gives me 5 times x plus 2. In the second term, once I pull out my x plus 2, what's left is the 3x. So I have, after my 5, I have a plus, a positive 3x. And again, you could get that if you did x plus 2 times 3x, you'd get 3x times x plus 2. And similar type of thing for the second one. If you take the second one, both of those terms have a b squared plus 1 in it. So my first term here, I'm going to pull out a b squared plus 1, and I need to put it in parentheses because I'm pulling out that whole thing. I'm not just pulling out like a b squared or just a 1. And when I pull that out of this first term, I'm left with a minus 2b. And then in my second term, this gets a little confusing. Some people want to do like the plus 0 here at the end. But instead, if I have this b squared plus 1 and I pull out a b squared plus 1, I'm left with a 1. And to kind of maybe show how that happens, earlier we talked about we're really taking and dividing things by the greatest common factor that we're pulling out. So if I have a b squared plus 1, that's all one thing, and I'm pulling out or I'm dividing that by a b squared plus 1, well, that there, the numerator and denominator are the exact same, so they just cancel each other out and give you an answer of 1. It'd be the same type of thing if you had like a, just picking a random number, a 5 divided by 5 as a fraction, and they're saying, well, what is that fraction? Well, we'd cancel out the 5's there and say that fraction equals 1. So we need to have a 1 right there. Factor by grouping, it's sometimes a little bit weird for when do you do factor by grouping. For starting out, the book's going to say, factor these polynomials by grouping. And then it's telling you this is what you have to do. By the end of the chapter, you'll probably be a lot better at looking at one and being like, oh, I bet it's factor by grouping. One thing that's kind of a good tip-off is if you have something with 4 terms, it's a pretty good candidate for factor by grouping. Until then, we'll kind of just tell you to do it. But what I'm trying to say is this. Okay, so if we have this here, we have this 4-term polynomial. Do you agree I could take and split it up into this and that? I really just wrote it exactly the same with a space in the middle. Fair enough? So sometimes if you're looking at these, there's not one thing, I mean there's a 2, and you could try to factor a 2 out of each of those, and that would get you part way, but you're able to get a little bit further if you do this factoring by grouping stuff. So what we're going to do is we're going to say, okay, I want to factor these, and I want to factor these, and then at the end you're probably going to find you had something like what we were just doing in Roman numeral 3. So if I just look at these first 2, what's my greatest common factor of the first 2? I could divide both of those by 2 and x to the third, yes? So I could divide those by 2 and an x to the third. If I do that, we want to say, okay, what's going to be left? So if I have my 6x to the fourth, 6 divided by 2 is 3. And then how many x's are left?
1.
1. So out of my 6x to the 4th, once I divide by 2, divide by x to the 3rd, I'm left with a 3x. This minus 4x to the 3rd. Negative 4 divided by 2 is? Negative 2. And then my x to the 3rd divided by x to the 3rd is just a 1. So we don't have to write anything there. So you okay with me factoring those first two, that first binomial? That makes sense? Now we look at that second binomial, this over here. I can divide 12 and 8 by 4. So I'm going to over here say, all right, I want to pull out a positive 4. So I'm pulling out a positive 4. And when I do that, what's left? 12x divided by 4 gives me 3x. A negative 8 divided by 4 gives me negative 2. Do you see it? Now this here is setting us up. This is why we did Roman numeral 3, so you could see how to do it at this point. But now this term here, we have one term because it's all multiplication, right? Parentheses make this all one thing. It's multiplied there. So this is all one term, and it has this 3x minus 2 in it. This is all one term, and it has a 3x minus 2. So do you agree I could, just like before, pull out a 3x minus 2 from both of those terms? And if I pull a 3x minus 2 out of here, this drops out. I'm left with 2x to the 3rd. So 2x to the 3rd. And then you guys are right, I have a plus 4. I'll say it a little bit slower if you didn't catch it. But now my second term here, when I pull out the 3x minus 2, I'm left with a plus 4, so I get that. All right, one more. So if I have this here, so 5x to the 4th, you can read it. All right, so we're going to break this thing up into two chunks. What's my GCF of this first part here? I can pull out a 5y to the 3rd. Once I do that, what am I left with in my first term? Just a y, right? So if I take this, 5 divided by 5 is a 1. Y to the 4th divided by y to the 3 is just a y to the 1st. Negative 15 divided by 5? Do we agree negative 3y? Negative 3, yep, because y to the 3rd divided by y to the 3rd, that just cancels out. So that's factoring that first binomial. Now if we take that second binomial, this here, all right, I'm going to pull what out of both of them?
1y to the 1st.
Yep, so I'm going to pull out a y to the 1st. I'm just going to do a positive y, not write the 1. Y squared, take out a y, gives me a minus 3y, take out a y. It's going to be minus 3. And now you'll notice my y minus 3 here is the same as my y minus 3 there. So I can take and factor this. Now both those terms have a y minus 3, so I can pull out a y minus 3. And when I take y minus 3 out of this first term, I'm left with 5y to the 3rd. And then when I take y to the 3 out of this second term, I'm left with my plus y. So that would be the final factoring thing for that one. All right, so factor with opposites. This first part, I'm just trying to show you a little bit of background you need to figure out this factoring by opposites. But what I'm trying to say is this. If I have a 5 minus x and I have a x minus 5, are those equal? Be careful before you answer. No, because one has a positive 5 over here, and one has a negative 5. One has a minus x or a negative x. One has a positive x. Agreed? So they're not equal. But if I would take, what could I do to this first one to make it look like the second one? If I change the positioning, you're right, that would give me, but it'd give me a negative x plus 5. So we're closer. But if I multiply by a negative, so now if I take that, so you got a good first step. But now if I say, if I have a negative 1 times x, do you agree that would give me, this times this would give me that? Negative 1 times what would give me a positive 5? Negative 5. So do you agree if I have this negative 1 here, I can make this look the same as that? And that's going to come up down below when we do this factoring with opposites. So this here, we're going to treat it kind of like our factoring by grouping stuff. And let me slide that up a little bit. So I'm going to say, all right, in this first chunk, so we have a 4-type polynomial, we can pull out a 5x squared. Agreed? Is it okay if I just kind of do stuff a little faster? 5x squared? So 15 divided by 5 gives me a 3. X squared divided by x squared, I don't have any x's left. Now I have this minus 10 divided by 5 gives me a minus 2. And x to the third divided by x squared gives me an x. So I'm up to there. Still with me? Okay. Now if I were to do that same thing for this second binomial here, I can pull out a 4, positive 4, so I'm going to do a plus 4. And now I'm left with x minus 3. Well, I'm not left with an x minus 3, I'm left with a 2x minus 3. Oops. So 8x divided by 4 gives me the 2x, and then negative 12 divided by 4, negative 3. We still good? Now if you look, this is disgustingly similar to this, but opposite. It's that scenario we had before, that instead of a minus 3, I have a plus 3. Instead of a plus 2x, I have a minus 2x. So to agree, if I multiply this by a negative, it's going to change it around to look more like that. So you could write a bunch of steps. Once you know what you're doing, people just say, okay, if I make this 5 a negative 5, now I'm going to be left with a positive 2x and a minus 3. And then I could copy this. First time seeing that might be a little bit kind of like, what's going on? So if you want kind of the steps in between, you could say, well, we could change the order and say this is a minus 2x plus 3. And then I have my 5x squared. And then if I want to make it a negative 1, I could say I have my 5x squared times a negative 1 times negative 1 times the negative 2x gives me a positive 2x. Negative 1 times the positive 3 would give me the negative 3. And then you could say, all right, I'm going to combine my 5x squared and my negative 1 to get me negative 5x squared. And this is that. The other way to do it would be to, Nick's exactly right, you could change the sign on the negative 4 and flip this one around. I like doing this one because typically you get x's before. This is in standard form. It's written in the right form. But then the last part, if we want to factor by grouping, we could say, all right, I have this here in the first term, exact same thing in the second term. So I'm going to pull out a 2x minus 3. And when I do that, I'm left with this first part in the first term, minus 5x squared. And I'm left with this plus 4 in the second term, so plus 4. And we're done. So probably kind of messed up and wrong. But try the homework. Keep the answer key close by. Do one, check it. Learn from your mistakes. If you made a mistake, do another, and kind of work through it that way. I think you'll be pretty successful.